Welcome to the series of lecture on engineering mechanics. This is Professor Murugan from Panimalai Institute of Technology, Chennai. In the first part of the lecture, we are going to discuss about what is engineering mechanics, what is the importance of engineering mechanics, and what are the classifications of this engineering mechanics, then the various concepts and assumptions, fundamental principles used for this engineering mechanics. To understand the importance of the engineering mechanics subject, we'll take an example of thermal power station. Thermal power station, which is a capacity of 200 megawatt. For 200 megawatt of electric power, in the thermal power station, we have to consume 2000 tons of coal per day. If you assume percentage of ash coming from the coal is 10%, then for 2000 tons coal we will get nearly 200 tons per day as the ash. This is to be disposed on daily basis. Then we need a cooling water of 50,000 kiloliters per hour, and a steam flow rate from the boiler we get 14 tons per minute, and the turbine blade speed approximately 160 meter per second to generate the power. For the successful operation of the thermal power station, we have to handle these materials and cooling water, steam. For this material handling, we need large equipments and machineries. Energy conversion should take place. By burning the coal, we are getting the thermal energy. This thermal energy should be converted into mechanical energy by using the turbine. Then this mechanical energy should be converted into electric energy by using a generator, electric generator. For this energy conversion, we need again machineries. The produced electrical energy should be transmitted to the required places. For energy transmission, also we need equipments and machineries. The machineries which are required for this thermal power station should be properly designed and manufactured, and we have to maintain all the machineries for getting the proper service life. For all these design, manufacturing and maintenance of these machineries and equipments, we need reliable calculation of forces acting on the components of each machineries. What are the speeds and acceleration to be faced by the components of the machineries, and the interaction between the forces and the motion we have to study. If you know all these informations, then only we can properly design and manufacture the required machineries and equipments for this particular thermal power station. The study of engineering mechanics subject will satisfy all these requirements. One example we have taken as a thermal power station. Like that, if you take any engineering application, we need to design or manufacture or maintenance the particular machineries and the components. We have to do lot of engineering calculations. For that, the knowledge of engineering mechanics is very important. That is why in most of the universities, this engineering mechanics subject is considered as the common subject for first year students. This engineering mechanics be a prerequisite for most of the engineering sciences subject. After knowing the importance of the subject, let us get into the definition of the engineering mechanics and the classification. Engineering mechanics is a science which describes and predicts the conditions of rest or motion of bodies under the action of forces. When you apply a force on a body, then we have to know what are the effect of this force acting on the body. For studying the effect of the force on a body, we need the knowledge of this engineering mechanics subject. In simple words, we can say behavior of rigid bodies under action of force we are studying in this subject. We can understand the interaction between the different bodies on which the forces are applied. This engineering mechanics is the foundation of most of the engineering science course. It is going to be a important prerequisite for many engineering subjects. In mechanics, what we are going to study here is if an external force is acting on a member or a body, then what are the effect it will produce on that body. That is the thing we are going to study in engineering mechanics subject. We are going to understand this engineering mechanics subject through series of lectures. First we will see how this engineering mechanics classified based on the nature of the material we are considering. The mechanics can be classified into three categories. One is rigid body mechanics, another one is deformable body mechanics, another one is fluid mechanics. In case of rigid body, when you apply a force to a body, it will undergo certain local deformation and also it will have some displacement, right? It will displace from one point to another point, that is called a displacement. And inside the body or inside the materials there may be some deformation take place. If you neglect that local deformation, then we consider that body as a rigid body. The study of motion of the rigid body under the action of external force is coming under engineering mechanics. If you consider the deformation due to the external force acting on the member, then it is called as deformable body mechanics, which is commonly known as solid mechanics or strength of materials. By considering the deformation of the body due to the external force, we can easily design that particular component or we can get the required size of the component. In fluid mechanics, the behavior of fluids under the action of the external forces, this is separate subject, fluid mechanics. Now we are going to consider only this rigid body mechanics, which is called engineering mechanics. This engineering mechanics is further classified into statics and dynamics. In dynamics, we have sub-classification as kinematics and kinetics. So you will see the definition of these terms in the next slide. So what is statics? Statics deals with the forces and their effects while the machine parts are at rest condition. If the component is at rest condition, then what is the effect of the external force acting on the member? So that we have to study, that is coming under the topic of statics. Statics deals with forces and their effect. Actually in engineering mechanics we are studying the relationship between the external forces and their effects. If the body is under rest, then it is coming under statics. When we study the forces and their effects, when the components or machine parts are in the motion, then we call it as dynamics. This study is dynamics. Now in dynamics we have two sub classification. One is kinematics. In kinematics we will study only the motion of the bodies without considering the forces acting on the body, without considering the forces which cause the motion. We will get the relationship between the motion parameters or motion variables like displacement, velocity, acceleration. So we will use the equations of motion in the kinematic study. Then kinetics, which relates the action of forces on bodies to the resulting motion. This is the actual mechanics which connects the external forces and the resulting motion of the body. Our ultimate aim is to study the kinetics of a rigid body, but we are going to start with the statics first, then we are going to study the kinematics, then only kinetics part. So in most of the universities also the syllabus framed like that only. First 2 or 3 units they will cover the statics part, then remaining 2 units they will cover the dynamics part. We are also going to do in the same way. First few parts of the lecture we will discuss the statics part, then we will go to the dynamics part. If you want to understand the kinetics of rigid body, first we have to know all these theories involved in the statics and the kinematics. Now we will briefly discuss about what are the various idealization or assumptions used in this engineering mechanics. First one is continuum. What is continuum? We know that each body is made of infinite number of atoms and molecules. The matter or the material is assumed to be continuously distributed to study the measurable behavior, because we cannot measure the behavior of the body in the atomic level. So that is why to get the measurable behavior we are assuming that matter or material is continuously distributed. That means when we apply a force over a body at a particular point like this, then it is assumed that this force is applied or acting all the atoms or molecule present in the body. That is concept of continuum. But in reality it is not like that. By assuming the materials or the amount of matter present in the body is continuously distributing, so there will not be any gap between the atoms or molecules, like that we are assuming. By doing this assumption we can say that amount of matter present in this whole body is subjected to same amount of force. By using this continuum assumption we are making the problem or job easy. This is one important assumption, continuum. Based on this assumption only we are solving all the mechanics problem. When you say continuum, then there are two types of continuum we can assume. One is rigid body. In the rigid body assumption, it is definite amount of matter, the parts of which are fixed in position relative to one another. Consider a body. If you take 2 points on this body, let us say this is point A and point B. Now before and after the application of the force, distance between these 2 points will remain same. That is called a rigid body. That means we are neglecting any local deformation happening inside this material or matter of the body. So that is why it is called a rigid body. So deformation under the external force is negligible. How it is neglected? Compared to the size of the body, the local deformation will be negligible, like that the concept of rigid body. And remember, in engineering mechanics we are not considering the local deformation caused due to that external force acting on the body. That is coming under separate topic or subject called strength of material or solid mechanics. Here we are going to consider the rigid body concept. Then one more type of continuum we can assume, that is called particle. What is particle assumption? A body whose dimensions are negligible when compared with the distances or length involved in discussion of its motion. Example, the study of motion of sun and the earth, right? Compared to the distance between the sun and the earth, we can neglect the size of the earth and the sun. Concept of the particle is used to develop the various principles involved in the engineering mechanics initially. Then those principles are developed for the rigid body. In case of particle, the particle denotes a body in which all the materials are concentrated at a point. The size of the body may be anything, but we are going to assume that body as a single point. That is the example given. If you want to study the motion of earth, with respect to sun, the earth can be considered as a single point. How it is possible? Compared to the distance between the sun and the earth, we can say the earth is a small point or particle. In case of particle, we can neglect the size of the body. By neglecting the size of the body, we will take some advantage in developing the various principle and theorem. After understanding the particle concept, then we will go to the rigid body. The same concept will be extended for the rigid body. That is the structure of the engineering mechanics subject. We have to understand these three idealization, which is to be remembered all the time. Continuum, by assuming this assumption continuum, we are saying that the amount of matter present at the body is continuous. By that way, we are assuming that whenever a force is acting on the body, that force is acting throughout this volume, right? There may be one particular point the force may be acting, but we can say that the force is acting throughout the volume of the body. There are two types of continuum. One is rigid body, another one is particle. In rigid body, we are considering the actual size of the body, but we are neglecting the local deformation happening due to the external force. In particle assumption, we are neglecting the size of the body by comparing with length involved between the two bodies considered for the analysis. So the particle concept, we are neglecting the size of the body. We will discuss about the basic concepts used for the study of engineering mechanics. Is very important. So using these concepts only, we can understand all the theorems and the principles developed in the engineering mechanics. The basic concepts, first we are considering the space. Space is described like this: collection of points whose relative positions can be described using a coordinate system. Suppose if you take any component or body, to place the body we need a space. Now the space should be defined first, in which the body is present. To define the space, we are using the coordinate system. It may be a rectangular coordinate system or cylindrical coordinate system, like that. So most of the engineering mechanics problems are solved by using the rectangular coordinate system. So here it is shown that in rectangular coordinates we have x axis, y and z axis, three-dimensional coordinate system. To fix the position of a point, we are going to use this x, y, z coordinate system. That is the position. The position of a body can be explained by using this coordinate system. Once you know the position, then only we can develop the concept of velocity and acceleration. To develop the concept of velocity and acceleration, we need the time. Time is the second basic concept, which is used for studying the relative occurrence of the events, right? All the physical phenomena are considered as event. So if you want to study or analyze the physical phenomenon, we need the time concept, and based on the time only we are studying the motion parameters like velocity and acceleration. Rate of change of displacement is velocity, then time rate of change of velocity is acceleration. This is the time concept. Then third one is mass. The mass concept is used to measure the resistance to change in velocity. So when we apply a external force to a member, the body will tend to displace from one point to another point. That displacement can be measured by using the coordinate system. The velocity can be measured by using the time concept. Now let us say we are applying same amount of force or same magnitude of force to two different material: steel, aluminium, copper, like that. How to differentiate the resistance to change in velocity, or how this material will resist the external force, right? For that comparison we can use the concept of mass, and also this concept of mass is used to describe the quantities that influence the mutual attraction between the bodies, which is nothing but the concept of weight. Then the fourth concept is force. We are saying that external force is acting over the member like that. So this force is considered as a vector quantity which has both magnitude and direction. What is a force? It is nothing but an external action of one body on the another body. That is called a force. So that external action is measured by the term force. Force is described as a vector quantity which has magnitude and direction. We have point of application and line of action. Everything we are going to discuss in the later stages. To solve any problem in mechanics, we need these four concepts: space to define the position of a body, time to find the relative occurrence of the simultaneous events, mass is used to measure the resistance offered by the material to the external force. Then the force is a description which is used for the action of one body on another body. Now we will discuss about the fundamental principles which are involved in this study of engineering mechanics. Based on these fundamental principles only, all the problems are developed. We will see these principles one by one. The first one is the parallelogram law. Then we have principles of transmissibility. Then Newton's laws of motion, first law, second law, third law, and Newton's law of gravitation. So each law has its importance in solving an engineering mechanics problem. We will see one by one. What is parallelogram law? In mechanics, we are dealing with the forces and the motion of the body. Both force as well as the motion are considered as the vector parameter. If you want to study about the forces and the motion behavior, we have to know about the vectors. So how to add two vectors? For that we are using the parallelogram law. So when you say a quantity, physical quantity is vector, then as per definition of the vector, it will have magnitude, direction, as well as it should obey the parallelogram law. That is the definition for a vector that we studied in our mathematics. So when you say two vectors v1, this is the vector v1 and v2 treated as free vectors. So there are different types of vectors: free vector, sliding vector, fixed vector or bound vector. So what is free vector? Free vector, there is no bound for the point of application of this vector and the line of action of this vector. That is free vector. Inside the body, let us say this is the body, we can place that vector anywhere. That is called a free vector. So the best example is, let us say a car is moving along a road. So if you want to measure the velocity of the car, that velocity vector may be placed anywhere inside the car, right? That is called a free vector. Okay. In the statics, we are going to see couple vector as a free vector, that we will see in the later part. So free vector, we can place the vector anywhere inside the body. There is no bound or constraint for the point of application or the line of action. The parallelogram law is applicable for the free vector. There are two vectors, free vector v1 and v2, which can be replaced by their equivalent v vector, which is the diagonal of the parallelogram formed by the two vector v1 and v2 as its two sides. So here we are showing it schematically. So this is the v1 vector and v2 vector, free vector. Now we are forming a parallelogram like this by keeping v1 and v2 as the two adjacent sides of the parallelogram law. Then we have to draw parallel line for V1, parallel line for the V2. We will get the parallelogram. Draw the diagonal of this parallelogram. Then this diagonal will be the equivalent vector, or we are going to say resultant vector V. So which will have the same effect of these two vector V1 and V2. That is called the equivalent vector. Let us say these two are forces. When you apply these two forces V1 and V2 on a body, then it will produce some effect. When you apply a force of V vector which is equivalent, this will produce the same effect of these two vectors. That is why it is called the equivalent or resultant vector. V1 plus V2 vector, this is the sum of the two vector which is equal to V vector, equivalent vector. We can find this equivalent vector by drawing this parallelogram using the two vectors as the adjacent sides. Note, if there are not free vector, so this law is applicable for the free vector. If they are not free vector, then you can sum them if and only if they have same point of application. That means if it is not a free vector, then this V1 and V2 should have same point of application like this. V1 and the same point we should have V2. Same point of application will be there, then only we can apply this parallelogram law. Right? That you have to understand. What is the use of the parallelogram law? To find the resultant or equivalent vectors. Right? If there are n number of vectors involved in the problem, then we can find the equivalent vector for all the n number of vectors. Or we can say we can easily find or do the sum of all the vectors using this parallelogram law. The extension of this parallelogram law only we have triangle law and the polygon law, that we will see later on. Next is principle of transmissibility. When we solve the problem, sometimes we need to change the point of application of the force acting on the body. If the point of application is changed, then the problem can be solved easily. So for that reason, this principle is useful. Principle of transmissibility. That means we can transfer the point of application of the force acting over a body, provided this point of application should be changed only along the line of action. This is the line of action of this force. Along the line of action, instead of this point of application, we can change this as the point of application. This is called the principle of transmissibility. Why they are considering like that? If we concern only about the external resultant effect, we are neglecting the local deformation. I think you remember that assumption we made, right? Rigid body. We are considering only the external resultant effect. So we are using this concept. We can slide the force along its line of action. So this force can be considered as a sliding vector. So along the line of action, we can change the point of application of the force. The two forces can be considered as equivalent if the magnitude and the line of actions are same, based on this principle of transmissibility. So a force may be applied at any point along the line of action without altering the resultant effects of the external force to the rigid body on which it acts. So based on this principle of transmissibility, we can change the point of application of the force. For example, let us say the force is acting from this side of the body, so it is treated as a pushing force, right? Now the same force can be replaced here along the line of action. So now it is like a pulling force, right? The magnitude and everything will be same. So a pushing force can be replaced as a pulling force by applying this principle of transmissibility. Why we are using this principle means when we solve the problem, we will understand the importance of this principle. Let us go to the next principles. Now we are using the three laws of motion developed by the Sir Isaac Newton. So Newton's first law, second law and third law we are going to use in the engineering mechanics. The study of rigid body mechanics is formulated on basis of Newton's laws of motion only. That is why it is called Newtonian mechanics. And when you say the first law, an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and in the same direction unless acted upon by an unbalanced force. That means if any other external force is acting on the body which is at rest or which is at the uniform motion, then it will continue its condition. It may be a rest condition or uniform motion. If you want to disturb that equilibrium, you have to apply one external force or unbalanced force. This is the statement. That is, by using this first law, we can say that when the body is in equilibrium, we can say the algebraic sum of the forces acting on the body will be equal to 0. This is one important relationship we are getting from this first law. This diagram will explain if there is an uniform motion which is disturbed by an external force, then the system will not be in equilibrium, right? So that you have to understand. So if you want to disturb an equilibrium, we have to apply an external force or unbalanced force to the system. Then only we can change the equilibrium position. That point we have to understand from this first law. What is the second law? Newton's second law of motion. The acceleration of a particle proportional to the vector sum of the forces acting on it, and it will be in the direction of this vector sum. So let us say the external force is acting on the body which is under rest or which is in the uniform motion, right? The first law we have understood that if you want to change the equilibrium of a body which is at rest or uniform motion, we have to apply an external force. Okay. Now second law states that if the external force is acting on the body, then the body will have displacement, velocity, acceleration, right? So now that acceleration which is caused due to that external force will be proportional to the vector sum of the forces acting on it. There may be n number of forces acting simultaneously on the body. So in that case, the vector sum of the force acting on the body, let us say this is a vector sum. The acceleration of the body or particle is proportional to that vector sum. That acceleration will be along the line of action of this vector sum. Here vector sum is nothing but the resultant or equivalent force. So we are getting one important relationship or important equation from this Newton's second law, which is F equal to ma, where this external force is proportional to the acceleration of the body, or in other words we can say the second law, the rate of change of linear momentum is proportional to the external force. In that way also we can develop this equation. F is equal to ma, very important equation which is useful for solving the engineering mechanics problem. So here this F is nothing but the resultant or vector sum of the external force acting over the body. This is the resultant acceleration of the body. So that acceleration will be along the direction of the resultant force, that we have to understand. Then third law, Newton's third law we studied earlier, that is for every action there will be equal and opposite reaction. That is the simple form of the third law. From this law we can understand that the forces always occur in pairs, right? That means the mutual forces of action and reaction between two particles are equal in magnitude, opposite in direction, and are collinear. That means let us say you are just applying a force over a wall. In return, the wall will exert a reaction force towards us, right? So this is the force applied, this is the reaction force. That reaction force developed by the wall will be equal in magnitude but in the opposite direction. So that is why we are saying that forces will always occur in pairs. if there is a action, definitely there will be a equal and opposite reaction. So that is the Newton's third law, which is very important in solving the engineering mechanics problem. So when we draw the free body diagram, we will use this one. So let us say this is the actual situation. We are applying just a force over a wall. So when you draw the free body diagram for this wall, this is the force acting on the wall. But when you draw the free body diagram for this man who is applying the force, then this is the reaction force acting over the man. That is free body diagram of this man, this one. This concept of free body diagram we are going to discuss detailedly in the forthcoming parts of lecture. So in the first law, we understand that to disturb the equilibrium, we have to apply external force. From the second law, we derive the expression F is equal to ma, that is acceleration of the body is proportional to the external force. From the third law, we understand that for each action there will be equal and opposite reaction force. That means forces always occur in pairs. Newton's law of gravitation, which is very important. From this law of gravitation, we derived the definition of weight of a body. What is this Newton's law of gravitation? It defines the attractive force developed between the two bodies which are at a distance of r meter, right? Let us say this is the body which has mass capital M, this is the another body which has mass small m, which are placed at a distance of small r. Each body will exert a force towards the another body, that is called attractive force. If you want to measure the attractive force developed between the two bodies, we can use this equation Gmm divided by r square, where this G is called the universal constant of gravitation. This is the constant value. Capital M and small m are the particle masses. R is the distance between the particles. Based on this Newton's law of gravitation, we can define the weight of a body which is placed on the earth surface. Let us say a body is on this earth surface, mass of the body is small m, and this is the center of the earth. So all the bodies which are present in the earth surface are attracted towards the center of the earth, that is acceleration due to gravity. All the bodies on the earth surface are attracted towards the center of the earth. What is that attractive force? That is measured by using this equation. So when you consider this capital M as the mass of the earth, small m is the mass of the body considered, and G is the universal constant, R will be the radius of the earth. Now this Gm and R square will become a constant, that will be equal to 9.81 meter per second square, which is called acceleration due to gravity, small g. So all the bodies which are present in the earth surface are attracted by this g value, right? This is called acceleration due to gravity. So we can say weight of the body W is equal to product of the mass and this g value, acceleration due to gravity. In the earth surface, the bodies will attract each other, right? This attractive force is negligible when compared to the attractive force developed by the earth. That is why we are having our normal life on the earth surface. Each body attracts the another body, but that attractive force is negligible compared to this gravitational force. That we have to understand. This is the Newton's law of gravitation, which is used to derive the important concept of weight of the body, W equal to mg. We are going to follow system of units in the engineering mechanics problem. We discussed the four basic concepts in the engineering mechanics. For the basic concept, we are going to use the units. The length, which is developed from the space concept, length, time, mass, and force. Out of these four, three of these kinetic units referred as basic unit, that is length, time, mass are called basic units, and the fourth unit is called derived unit, right? This is based on the definition from the Newton's second law, F equal to ma. So mass unit is kilogram and the symbol is kg. Length unit is meter, symbol is m. Time unit is seconds, symbol is s. Force unit is Newton, symbol is n. These units based on the SI unit system. International system of units is SI. Here the basic units are length, time and mass, and the force unit for the force is derived 1. So how the force is defined? 1 Newton force is nothing but the amount of force required to make 1 meter per second square acceleration in a 1 kilogram body. That is the definition for 1 Newton. These are the unit system we are going to follow for solving this engineering mechanics problem. For 3 basic units, mass, length, time, and 1 derived unit, force, we have to understand. For mass we are using kilogram, length we are using meter, time we are using seconds, force we are using Newton. In this part of lecture we understand the importance of the engineering mechanics subject, and we discussed about the assumptions or idealization used for solving this engineering mechanics. What are the idealization? Continuum, rigid body and the particle. Then we discussed the basic concepts used for solving the problem: space, time, mass and force. Then we discussed the fundamental principles used for solving this engineering mechanics: parallelogram law, principle of transmissibility, Newton's laws of motion, first law, second law, third law, and Newton's law of gravitation. Then we discussed about the unit system which is followed in the engineering mechanics. In the next part of the lecture we will start the statics of particle. Thank you for your passion listening.